Good morning, students. I am Manikant Mishra, Modern Innovation School, New Area. Today, I am going to discuss Class 9 Chemistry Matter, Lesson 1 Matter in Our Surrounding. The part yesterday we have already discussed the states of matter. The matter exists in three states of matter, that is a solid, liquid and gas. And also we have already discussed the factor which are responsible to decide whether the sample of matter is a solid, liquid and gas. Once again, just I will remind you, the two important factors are responsible to distinguish one state of matter into another state of matter. That is the intermolecular force of attraction and the kinetic energy. This kinetic energy often it is also called thermal energy. Now this intermolecular force of attraction depends on the intermolecular space. If the intermolecular space is less, intermolecular force of attraction will be strong. If the intermolecular space is more, then intermolecular force of attraction will be less. On the other hand, if the motion of the particles are high, then kinetic energy will be more. It means particles are freely to move. Now, yesterday already we have talked about the sample of matter A, in which intermolecular space in sample A is very less. So, intermolecular force of attraction is in sample A is very high or very strong. And since the intermolecular space is very less, the particles have the very restricted motion. That's why kinetic energy of sample A is very less. So a sample of matter in which the kinetic energy is very less and intermolecular force of attraction is very strong, that sample of matter exists in the solid state. A sample of matter in which intermolecular force of attraction is very strong and kinetic energy is very less, then that sample of matter exists in the solid state. Now, some of the characteristics of the solid state, like a in a solid state, the matters are incompressible. It means if you apply the pressure, it cannot be reduced into their shape or size comfortably. So that's why under ordinary condition it cannot be compressed. So in a solid, matters are incompressible. It is a rigid in nature due to strong intermolecular force of attraction. The solids are rigid. Due to strong intermolecular force of attraction, the solid is rigid. Solid have fixed shape and volume. Solid has higher density. Due to less intermolecular space between the particles, it has a high density. Due to restricted motion or strong electrostatic force, a strong intermolecular force of attraction, due to restricted motion or strong intermolecular force of attraction, the diffusion in a solid takes place almost negligible. There is almost no diffusion takes place in a solid. So these are the few characteristics of a solid. Now let us come to the sample B. In this sample B, if you compare with sample A, here there is a little more intermolecular space between the particles. The intermolecular space is a little more as compared to sample A. So if intermolecular space is a little more than sample A, so obviously intermolecular force of attraction will be little less as compared to sample A. And due to little more intermolecular space, the molecules are little getting more space to move, and it moves in rectilinear motion in 2 dimensions. Its particles are able to move in 2 directions, also called rectilinear motion. So little more kinetic energy and little less intermolecular force of attraction. This makes it different from the sample A. So any sample of matter in which intermolecular space is little less than the solid and little more kinetic energy than solid, that sample of matter exists in a solid state, liquid state. Any sample of matter in which intermolecular space is little more than solid and little more kinetic energy than solid, that sample of matter exists in liquid state. So here there is a very delicate balance between the intermolecular force of attraction and kinetic energy. So now the few characteristics of a liquid. First, liquid has a fixed volume. Like if you take 100 milliliter of water in a beaker and that 100 milliliter of water you transfer into conical flask, again it shows the volume of water 100 milliliter. So it shows that liquid has a fixed volume, but at the same time the water present in a beaker and water present in a conical flask have different shape. Again, if you transfer in a round bottom flask, the same water if you transfer into a round bottom flask or ordinary glass tumbler or in a bowl, then we see in different circumstances, in a different condition, always the shape of the water gets changed. With this, what we can say that liquid do not have fixed shape. So liquid has a fixed volume, but it does not have a fixed shape. It takes the shape of the container in which it is kept. Due to less intermolecular force of attraction and little more kinetic energy, the particles are able to slide along the wall of the container. That's why when you pour the water on the surface, it starts to move from higher level to lower level due to less kinetic energy, a little more kinetic energy and less intermolecular force of attraction. Next, liquid has a less density as compared to solid because of little more intermolecular space. Next, liquid has a more diffusion as compared to solid. You take a water in a beaker or even in a bucket at your home, you can do it, and add a drop of Dettol. You see, immediately whole water gets a smell of Dettol. Whole water gets a smell of water. Or you are enjoying during the Holi with the color. When a crystal of color you are adding in water, whole water gets colored. This shows that diffusion is very fast in the liquid state. So these are the few characteristics of liquid. As I said, liquid, neither it has a fixed shape nor it has a fixed volume. Liquid has a fixed shape. Liquid has a fixed volume, but it does not have a fixed shape. It takes the shape of the container in which it is kept. Next, liquid has less intermolecular force of attraction as compared to solid. Liquids can move freely as compared to solid because of less intermolecular force of attraction. Liquid has less density as compared to solid. Liquid has higher diffusion rate as compared to A. But this diffusion depends on the thickness of the liquid or the density of the liquid. Like you can do at your home. Like if you take the water in a two different glass, made up of glass. In one glass you add honey, and in another glass you add Ujala, blue, Robin blue or Ujala. You see, the glass in which you are putting the Ujala or the blue color is sprayed fast, but at the same time the glass in which you have added the honey spreads slowly. So with this we can say that diffusion depends on the thickness of the liquid. Diffusion depends on the thickness of the liquid. Also we can say the density of the liquid. Less density, more diffusion. Less density, more diffusion. So this is about the liquid. Now come to the figure C, a sample C. Here you see the molecules are far apart. The intermolecular space is very high. Intermolecular space is very high. So if the intermolecular space is very high, what will happen? Then intermolecular force of attraction, intermolecular force of attraction is very less. So in this sample of matter, in a sample C, you see that intermolecular space is very high, due to which intermolecular force of attraction is very less. So, now, due to less intermolecular force of attraction and due to more intermolecular space, the molecules are free to move. It means the kinetic energy in this sample, kinetic energy is maximum kinetic energy in this sample is maximum. First of all, intermolecular space is very high, due to which intermolecular force of attraction is very less. They are loosely bonded. Among them, the force acting within the molecules is very less, due to which the molecules have freely motion. So the kinetic energy is maximum. So any sample of a matter in which intermolecular space is very high and kinetic energy is maximum, that sample of matter exists in the gaseous state. A sample of matter in which intermolecular space is very high, intermolecular force of attraction is very less, and kinetic energy is maximum, that sample of matter exists in the gaseous state. Now, the characteristics of a gaseous state. Now, neither the gas has a fixed shape nor it has a fixed volume. If you keep the gaseous molecules in a cylindrical container, it takes the shape of in the form of a cylindrical. If you keep it in cubical box, then it takes the shape of a cubical box or cubical box. So it means the gas has not fixed shape. Also, suppose the gas is 1 kg and the cylindrical container has a capacity of 5 kg, then it occupies whole space. So it shows that the gas do not have fixed volume also. So one of the important characteristics of the gas, neither it has a fixed shape nor it has a fixed volume. Now, gases are highly compressible. That also you are enjoying during the Holi. Like if you take 2 pichkari or color spray. If you take 2 pichkari and at the nozzle you fix 2 rubber cork and remove the piston through which you are pushing, that is called piston. You remove the piston from both the pichkari and then in one pichkari you put water and in another pichkari you don't put water. Now again you insert the piston. What happens? The pichkari in which there is a water is very difficult to push inside, whereas the pichkari in which you have not added the water, it means there is air, you can push it easily. So what this activity gives us information of, what we can conclude the observation. With this activity, the liquid cannot be compressed so much, but the air can be compressed easily. Why? Because of high intermolecular space. High intermolecular space. So gases are highly compressible in nature. Gases are highly compressible in nature. Next, due to large intermolecular space in a gas, it has less density as compared to liquid or as compared to solid. Now, one of the important characteristics of a gas exerts pressure. Gas exerts pressure. How is it possible? You see, due to high kinetic energy, these molecules collide among themselves as well as to the wall of the container. It exerts a pressure due to high kinetic energy or less intermolecular force of attraction. It exerts a force on the wall of the container as well as they collide among themselves. Since it exerts pressure on the wall of the container at a particular area, so as we know that the pressure exerted per unit area, force exerted per unit area is called pressure. Since these gaseous molecules exerts a force on the wall of the container, since gaseous molecules exerts force on the wall of the container, and as we know that the force exerted per unit area is called pressure, that's why here we can say the gas exerts pressure. So these are the few characteristics of the gas. But one more thing, the diffusion of gas is very fast. Diffusion of gases is very fast, and this diffusion also depends on the temperature, because the temperature increases the kinetic energy. Temperature increases the kinetic energy, due to which the diffusion also becomes faster. It is one of the reasons that hot food, the smell of hot food can be experienced from a distant place. The same food, when it is cold, if you go closer to it, then only you can experience its smell. So the diffusion in a gaseous state is very high. So once again, let us conclude the characteristics of a gaseous. The gas has neither fixed shape nor fixed volume. Gas has a less density as compared to liquid and solid. Gas has very less intermolecular force of attraction. Gases has very high kinetic energy. Gas has highly compressible. Gases has very high diffusion. Thank you. Have a nice day.